This is a demonstration of how to use the state machine elements of the Quartus 2 software. As you saw, there was a state machine table, and this is a state machine diagram. And then you have actually 4 states here. And now we're going to show you how to use the state machine tool that exists with the Quartus 2 program. And now, by this stage, you have already used the Quartus 2 program, and you know how to do the schematic capture file and then run it. So you just create a new project here, and as you've done it before, or if you want to have it in a certain folder, you put it in a certain folder, and then you have to give the file a name, and then we just have to change the selected device here. Stay with the default here. We can actually change it to max series, and the chip number is selected. Alright, and here is starting a new project. Alright, now we have to have a new file here, and this time we just add a state machine file. Now there's one of the two ways to do it. We use the wizard here to input the table there, so we go from the this is a way to go actually from the table. It's a synchronous machine. You have a clock, and then you want to reset. So the default, this is the default that the program comes in. You can have as many as the state you want, and then as many as the inputs and outputs that you want here. In the example we had 4 different states here, and then we had 1 input and we had 1 output. Now this one here right now, you're not worried about the output right now. You will worry about see how many inputs you have. You have 1 input, you have 1 reset, you have 1 clock, then you have 4 states here. Then the rest of it is now trying to understand how those relationships are defined. So and you can rename this thing to anything you want to. In this case, I'm just changing the input name to X, so it will reflect what we had on the table, and the states can change to anything you desire. So you can rename them to whatever you want. Now we have to define the state. So going back to the table, right now we have defined like a state 1 going to state 2 when the input is 1 on the second line. The same state when X is not 1. And remember, if you had more than 1 input, you can use the basic logic as inputs, which is AND, OR, and inverter, to define the relationships between the different inputs. Right now, because we have only 1 input, the input either is 0 or 1, but that could be as sophisticated as possible that that you want it to be. So we just defined here the state from the table. This is right from the table that I just showed at the beginning of this, and putting the desired relationships here. Now, in this screen, next one is actually doing the output. So we call this Y, so we're going to rename it to Y, and then the next clock, what. So we have to go back to the table and look at what conditions actually the Y was 1, and define those states and the condition, which means the input condition on that state. And so we solved for, there were only 3 times that the Y was 1 if you look back the table, and then going and what the state it was and what was the input on that state. In this case, it was a state 2, and X is not, input is 0, and then state 1 and state 4. Those conditions you had a 1. So we hit next here. This is the summary. You have 4 states, clock, reset, and input. And and it will give you the state diagram here. Here we save it, and then we can get a HDL file from it. So we hit the generate the HDL file. In this case, it will be VHDL. So here we're just gonna ask it to generate a VHDL file, and here it is. You go through it and look at it, but then basically it's going to perform that. The reason we use that tool because we didn't want to actually sit down and type the whole thing. And alright, so this is the HDL file, as you can see. Okay, now the next stage is to run the project. So we're going to run it. And start so we're going to run the project, compile it basically. And then you have to have a vector waveform in order to be able to display the output. So we're going to create a new vector waveform like we've done on a schematic capture. So better be the same name as your file. And then defining the end time and defining your grid scales. And here we have to list all the files we had here, and there it is. And we have to add a state machine condition here. Then we'll have to set up a clock for it. You do that manually, or just set up the time for it. You want to reset this thing at the beginning. Make sure that everything starts as a default. So the reset is there, and then you want to define the inputs. And you can do this thing manually. Actually, you can drag it up or down by selecting that specific area and then force it to be high or low. And then save it, the vector waveform, and then compile it, and then run the vector waveform afterwards. So this is going to run. Here it is, no errors, 2 warnings, and here it is. These are the finite states, so you got all the states there, and if you zoom out, you should see the whole thing. Or we can just fit it in the windows. Oh, here it is. And this corresponds to actually your table. You can actually study it and look at it. And in order to find, say, going from state 1 and state 2, when the input is 0, you hit the clock, and it shows right there. Now, state 3, input 0, output is 1, and state 1, input 1, go to state 2, output is 0. So if you check back with the state diagram, or if you check back, and everything is exactly the way it's supposed to be, it's going to reflect the table.